Precision bearings are built with intentional looseness, an empty space called radial internal clearance. Miscalculate this gap by a fraction of a millimeter, and the bearing will destroy itself. Take a heavy-duty roller bearing being installed onto a motor shaft. To keep metal from binding, factories leave a microscopic gap between the rollers and the outer ring, but that gap shrinks instantly. Forcing the bearing onto a slightly larger shaft stretches the inner ring outward. Then the motor spins. Friction makes the inner ring hotter than the outer housing, expanding the metal further. This shrinks the gap down to its final operating clearance. Start with too little factory clearance, and thermal expansion pushes this gap below zero. The crushed rollers trigger catastrophic seizing. But if the gap stays too wide, the load isn't shared. A single bottom roller takes all the force, causing severe metal fatigue. Maximum life is only achieved by choosing an initially loose clearance that perfectly offsets that exact thermal expansion. So what happens to that heavy-duty motor bearing from the start? Once the machine hits operating temperature, all of that intentional factory slop vanishes into a perfect frictionless fit.